Okay, everybody, this is notes for 1.5. We're going to be adding and subtracting real numbers. Sometimes these are called directed numbers because you use the sign in front of the number to tell you, like, if I had a number line, which way do I go on my number line? Okay, so we use that a lot today. Got a couple definitions here. We have absolute value. Absolute value and opposites are going to be kind of working together a little bit. So let's take a look at the definitions. For absolute value, it's a positive number, and distance is always positive. Okay, so distance from a number and 0 on a number line. So this is a 0 right here. Okay. So how far is something from 0 on a number line? So if I had a number line, and I had 0, and I had +4 and -4, they are both the same distance from 0. So distance in this case should always be positive, and that's kind of the reasoning behind absolute value. All right. Next one is opposites. Two numbers that are the same distance from 0. Okay, so -4 and +4 aren't the same number, but they're the same distance from 0. Okay, so in this case, with a number line, they're asking just a really simple math problem here. What's 3 + 5? Well, we know it's 8. Okay, all right, but if I start at 0, and the first distance they told me from 0 is 3, and then I'm going in a positive direction. Now, plus sign tells me go in a positive direction. Well, I'm still going to go 5 more, and I get to 8. Okay, so I'm using this to kind of help me tell me which way to go. I can go left or right. It tells me to go right. Okay, for this problem, so using the same numbers, except now I've put a negative sign in front of the 5, so I can really rewrite that like that. Once again, I'm going to start at 0. I'm going to go, and 3 is a positive number in this case, so I'm going to go to 3. But now it tells me to go in a negative direction, so I'm going to go negative direction 5, and that's going to get me at -2. Okay, so we're using a number line here to kind of see which way to go, and it helps me get to where I need to be, in this case -2. Okay, got a different problem here now. So once again, always starting at 0, because I'm worried, theoretically I'm always starting at 0, going a distance from 0. In this case, the first number is a -3, so it tells me to go in a negative direction, and I went 3, but then the next sign's plus. So it's telling me now to go in a positive direction, and I'm going to go 5, so that ends up getting me at +2. Okay? All right, so I know that's hopefully it seems pretty easy, but we're trying to get you guys to understand direction and how this is affected when you're adding and subtracting stuff, so that we don't make little tiny mistakes when it's a bigger problem. All right? So once again, I'm going to start at 0. I got a -3 as my first sign, so I'm going to go -3, or the negative direction. I could rewrite this equation like this. So once again, I'm going to go in a negative direction. I'm going to go 5 from there, and that's going to get me to -8. Okay, so hopefully that's pretty straightforward. And if you get confused, you could sketch a little number line out and kind of do this little game here too to help you. But really, this is to help us understand how to use directed numbers and not make little tiny mistakes with bigger problems. Okay. All right. For these, we're just gonna, you could draw a number line if you needed to. And because I'm adding, I could switch this around and make it look like that. Okay, the book might do this to you, but these two are the same thing. okay? So sometimes students like to turn things around just because it's easier for them to see it. It's what you're comfortable with. But when I'm adding those, I should get a -5, okay? And here, what I kind of tell students, I'm adding, but I'm adding 2 negative numbers, so I should get a bigger negative number than the biggest negative number I started with. So just adding those two together gets me 20, but I knew the answer had to be negative. Okay, so that's another way to kind of think about how to do those kinds of problems. You know, here, because I'm adding, I could flip this around. Okay, and some students like to see it that way. You know, we kind of learned that always the biggest number comes first, and you know, I changed it to a minus sign because that was a negative number. All right, so when I subtract that, I believe I get positive 4.7. Now, why do I get a positive number? Well, which number is bigger? And I'm going to ignore this for a second. Which number was bigger? 9.5 or 4.8? Well, 9.5 is bigger. What was its sign in the original problem? Well, it was positive because there was no negative sign in front of it. So my answer has to be positive. So that's kind of a common sense thing. And sometimes we don't use common sense. We don't think. We're just kind of blowing through stuff and not being able to do that, okay? All right. This next problem, we got to remember the rule. So we got a little bit of work before we can even get going. I'm adding two fractions. And when I add fractions, the denominators need to be the same. So I've got to change these. I'm gonna just kind of rewrite it first. I got to change the denominators to them being the same number. So I'm looking at what does 4 and 6 go into. So hopefully some of you guys said 12. So the denominators both need to be 12 now for me to be able to add these together. But when I change the denominator, I have to change the numerator. So what did I do to the 4 to make it a 12? I had to multiply it by 3. So I have to multiply the top by 3. And that's going to get me 9. Okay. The second fraction to get 6 to be a 12, I had to multiply it by 2. So I'm going to have to multiply the top by 2. And that's going to get me a -10. Okay. Now I can add these together because the denominators are the same. Now if the denominators are the same, I'm just going to keep them whatever they are, in this case 12, and I just add or subtract the top. So really the top says 9 minus 10, that gets me -1. Okay, so that's my answer. All right, a couple rules here that we need to kind of deal with. When I am subtracting a negative value, I'm kind of like a soldier or someone like in a band, marching band. When they're marching, they'll march straight and then they'll make a quick turn and go in the opposite direction. Well, I like you to kind of use that analogy here. This is the minus sign is telling me to go in one particular direction, but then this minus sign is going to tell me to turn around and go the other way. So I would really, if I'm subtracting a negative, it forces me then to make that positive, okay? So some of you guys, let me erase this and do this again. You know, when you were younger, some other math class you had, like in middle school or even before that, they made a little rule to kind of remember what to do. If you see two negative signs, we're going to zip it and zap it, and that changes the signs to positive, okay? And then, you know, you could even, if you wanted to, if you'd like to see things a specific way, you could change that, and 13 minus 8 is the same as -8 plus 13. Both of them should get you an answer of 5. Okay? All right. So I don't like to confuse you, but sometimes, you know, when I do numbers like this problem right here, I like to, you know, do that little thing I said earlier. Which number is bigger, 3.5 or 12.5? Well, obviously 12.5 is the biggest. What's the sign in front of it? It's negative. So that means right off the bat, my answer has to be negative, okay? And then, so some kids will have a difficulty with that. I'll do this. What's the difference? What's the difference between 12.5 and 3.5? How far apart are they? And they're about 9 apart, so my answer is going to be -9. So there's different ways to think about adding and subtracting directed numbers, okay, or numbers that have different signs. And sometimes it's just using a little bit of common sense and remembering what your answer should be, okay? And take your time until you get used to that, okay? All right, so a couple rules here. It's always true that A plus B equals B plus A for all real numbers. But is the same thing true for subtraction? Does the order matter? Well, sometimes with the letters we get kind of mixed up. So I'm going to call A 4 and B 3, okay? Well, I know 4 plus 3 is 7, right? So remember, that was A, and this was B. And if I take this little rule that they put up here, I'm going to flip it. Did I still get 7? Yes, I did. So does order matter when you're adding? And no, it doesn't. So order does not matter when adding. Okay, so I can flip it, change it when I'm adding, and I'll still get the same answer. Okay, but I'm going to erase this here. You don't need to. If you have room somewhere else, write this down though. I'm going to use the same numbers, 4 and 3 for A and B, and I'm going to flip it. So 4 minus 3, well, that gets me 1, right? But if I flip it, I go 3 minus 4, do I still get 1? I don't. I get a -1. Okay? So order does matter when I'm subtracting, okay? So we kind of proved here that this little rule right here, that I can't flip it because I'll get different answers. I need to get the same, okay? And then this question says, what values of A and B does A minus B equal B minus A? And the only one numbers I could think of is that both A and B have to equal 0 for that to be true. Okay. All right. So last question here. And so I'm going to draw a picture. So I really emphasize to students that when you get these word problems, draw a picture. And I'm not an artist, so don't laugh at me, but you know, just seeing things helps me to understand what I need to do. Okay, so let's read it first. Can't draw a picture unless we read it. A reef explorer dives 25 feet to photograph coral and then rises 16 feet to travel over a ridge before diving 47 feet to survey the base of the reef. Then the diver rises 29 feet to see an underwater cave. Okay, so obviously he's diving. We don't know if this is a lake or the ocean. I'm going to say it's probably the ocean because there's coral in a reef. I don't know of a lake that has that. So let's just do this. Humor me. We're going to draw the water because obviously the diver had to start maybe out of a boat or off of a pier or something. And let's do this. So the diver's going to dive 25 feet. Okay, and I'm going to label that. Okay. And then he's going to rise, or she's going to rise 16 feet to go over some ridge, something under the water. Okay. And then they're going to dive 47 feet to see the bottom of the reef. Okay. And then at this point, the diver is going to rise 29 feet. And there's a cave here, okay? I'm gonna go explore the cave. So obviously from my picture, I can still tell that the diver's underwater, all right? But in the water, the diver's gone both down and up in the water. And one thing we should kind of say here that the water level is at 0. So when they dove down, they actually went in a negative direction from 0. When they dove up or swam up, they can't dove up. They're going to go in a positive direction, and then they went down again, so that'd be a negative, and then they went back up 29 feet to the entrance of the cave. Okay, so what I've done is created a math problem. All right, so let's write it out. 0 minus 25 plus 16 minus 47 plus 29, and that's going to get me an answer. How deep is this diver in the water? Now, we've got to understand, I believe he's still underwater, so my answer's got to be negative. So hopefully that makes sense. That's common sense. From my picture, I should probably be able to tell he's still underwater. Okay, so let's add these together and let's just see what happens. So 0 minus 25 is a negative 25, but then I'm going to add 16. I get to negative 9, and then I get a negative 47. So, I'm adding two negative numbers. I should get a bigger negative number. I'm going to get negative 56, but then I'm going to add 29, and that's going to get me to negative 27. So that entrance to the cave is 27 feet below the surface. Okay, so draw yourself a picture. From the picture, I was able to write out some kind of math equation, and I was able to get an answer using directed numbers. Okay, so help yourself with pictures and use number lines. We could have drawn a number line too and kind of done that to help you out with finding the answer. Okay, all right, I believe that was it. So make sure you get the homework done. If you have any questions, please make sure that you call me or email me, and we'll try to work it out together. Take care.